Today we're cracking open Mark 11, my latest rig that's built to be so whisper quiet that you'll forget it's even running. This is my very first build rocking a custom water cooling loop, and in this video I'm giving you a quick rundown of everything I learned, plus some tricks you can steal for your own setup. If you're strapped for time, no worries, timestamps are down in the description. Jump to whatever section you're interested in. The main challenge this build solves is keeping my Intel Core i9-13900KS from going full meltdown, while still keeping everything hush-hush for a studio environment, as this CPU can draw over 300 watts and it thermal throttles like a reactor with xenon poisoning, if you're not careful. So that's a headache I dealt with in my previous builds, so I took all of those lessons and baked them right into the Mark 11's design. Parts cost an arm and a leg these days, so I'm going for longevity here. A custom loop like this is a big investment, but I'm planning on running it through a few generations of hardware. So even when computing demands blow up down the road, this cooling setup should handle it like a champ. Alright, let's dive into the nitty-gritty of what makes this thing tick. To keep this rig whisper quiet, I had to roll out some nifty engineering tricks. First of all, I'm rocking a dual-radiator setup. Why two? Because that redundancy gives me excellent headroom for heavy workloads, and it lets me split the cooling load between idle and full performance modes to keep the noise in check. Everything fits snug inside Fractal Design's Define 7XL, literally the best desktop case ever made. Changed my mind. It's built like a tank, it has a ton of space, and it's super flexible for any future upgrades I throw at it. And no, nobody's paying me to say that. On the menu today we also have PWM control of fans for low RPM, custom fan curves using this handy and free software called Fan Control, self-priming pump setup, RPM offsets to cut down the fan interference noise, and some air pressure tweaks to manage dust. Because who wants a dusty beast, right? Before we jump all into the juicy details, big shout out to Bauer and Jay's 2 cents for their killer videos. Their content has helped me piece together the water cooling side of the build and level up my knowledge. Alright, let's talk airflow. Regular 3-pin fans just don't cut it for a studio environment. They can't spin slow enough, and at low voltages they sometimes just stall around 40% or something, which is not ideal if you want absolute silence. That's where PWM fans step in. They got that 4th pin for direct speed control, so the fan's driver circuit has always full power, letting it spin super slow without power getting cut. For this build I went with Noctua's Chromax fans, mostly for their solid low speed performance and because they're black, with a splash of yellow in my setup. Specifically I'm running 4 NFA 12X25 PWM fans on the top radiator. They're static pressure optimized, which means they're great for radiators, and 3 NFA 14 PWM fans on the front radiator, and slapped one more NFA 14 on the back as an exhaust. That last one keeps the motherboard nice and cool if the top radiator fans are not spinning. Now, I don't recommend you do this at home, but my power supply fan was on its last legs, so I swapped it out for another Noctua NFA 1225 and added a thermal sensor on the main heatsink. That way I can run the power supply fan on a thermostatic fan curve. Total nerd move, but super handy. All in all, there are 9 fans in this rig. They can each spin really low speeds while still pushing enough air through the radiators and around the motherboard. And then comes the disclaimer. I did get these fans from Noctua for free, but they didn't pay me to say any of this. This video is not sponsored, and honestly I would have used Noctua products anyway because of the build quality, reliability and the sweet 6-year warranty. Longevity was a huge part of my design, so it's a no-brainer. Noctua recently released a new lineup where fans come in pairs with the 50 RPM speed offset, which cuts down on that annoying interference noise you get when multiple fans are spinning in sync. I of course stole that idea. Every other fan on my top and front radiator are hooked on a different control channel, so their speeds are slightly offset. That means 4 separate radiator control channels in total. If your setup doesn't allow for separate software control of fans, buying the pre-paired fans is an easy solution to get the same effect. Alright, let's talk about the heart of this cooling loop. I went with Alphacool's parts for everything. I did consider EK at first, but they've some hiccups lately that made me worry about their warranty, build quality down the road and replacement part availability. Alphacool is a German brand I haven't heard anything bad about, so I figured to give them a shot. Turns out the experience was pretty good, though their email support was a bit slow. They still got the job done and my RMA went smoothly. The first water block I received from them had a faulty LED strip. Kicking things off is the Eisbecher Aurora D5 pump reservoir combo. After digging into a bunch of options, I landed on the D5 because of its known high flow rates, proven reliability and long-term durability. I really like how the pump uses liquid as a bearing while keeping the coils outside the water space. The reservoir being directly above the pump makes the whole thing self-priming, so maintenance is way easier. Instead of controlling the pump speed directly from pump's RPM signal, I wired up Alphacool's ES flow sensor as the pump's speed sensor in the fan control app. This sets up a feedback loop. If the flow goes down, maybe from a kink tube or random gunk buildup, the pump automatically speeds up until the desired flow rate is back on target. I used hardware info sensor customization to convert the sensor's tachometer reading into liters per hour, working off the coefficients I calculated from the sensor's table that was delivered with the sensor. Nerdy, fun, completely unnecessary. The big glass reservoir also helps by adding thermal mass to the system, so my fans don't have to ramp up the second CPU spikes. Plus, it gives me a clear view of the coolant and has addressable RGB for that futuristic bling. Additionally, I added some edgy-looking custom sublimation printed webbing around the case for added style points. Alright, let's talk water blocks. These things might look simple, but they're really the star of the show. For my CPU, I went with Alphacool's Core 1 Aurora because, according to tons of third-party benchmarks I checked out, the Core 1 series kept coming up on top. I dig the minimal look, though the RGB is kinda weak if you already have some sort of crazy light show going on. I really didn't need to water cool my GPU, but for extra €170 I thought why not? So I threw in Alphacool's Ice Block Aurora, designed for RTX 4090 Strix and tough cards. It fit my GPU perfectly, was easy to grab directly from Alphacool and came with a sleek backplate and everything needed for the installation. One downside, the LEDs are visible through the plastic since there's no real diffuser, so it's not the cleanest look. But honestly, performance is rock solid, so I'll take it. For thermal paste, I picked Thermal Grizzly's Cryonaut. Sure, it's about €15 extra, but considering the total cost of the build, that's nothing. It seriously matters what you slap between the chip and the cooler. The built-in paste spreader was kinda pain though, so I ended up using the good old tape the edges and spread it with the credit card method, because the stuff is pretty thick. Next up, the radiators. I have got 2 of them running in series. On top there is a 45mm thick 4x120mm radiator, which alone could handle the entire system easily, but I wanted the thing to be ultra quiet, so I added a 3x140mm rad in the front too. The idea is that the front radiator handles the basic cooling, while the system is in idle, and the top radiator fans kick in when I really crank up the workload. There is also a more creative reason for 2 radiators: VR sessions. My cat loves to hop on the case while I'm wearing a headset. If the top radiator gets blocked by my furry friend, I still got solid 4 or 5 fan slots worth of unobstructed radiator space to keep the temps in check. I also went at the case mounts with a rotary tool to give the radiators a bit more breathing room. Not gonna lie, I wouldn't recommend that unless you really know what you're doing. Mounting radiators is now a total pain in the ass. Lastly, I thought about using cross-flow radiator on the front, but it didn't fit. Pro tip, read the manual carefully. Turns out Fractal's got a different radiator layout spelled out in their manual. My bad for not checking it beforehand. To help cool the motherboard and keep the dust to a minimum, I've been playing around with differential air pressure control. Basically, I aimed for a slight positive pressure inside the case by balancing the intake and exhaust fan speeds. A tiny positive pressure helps to cut down on dust sneaking in and make sure the radiators get steady flow of fresh air. I did briefly consider using a differential pressure sensor to adjust fan speeds automatically, but the pressure differences we're talking about are super small, and a sensor sensitive enough for that would have been super expensive, and I didn't see enough benefit to justify that. Another critical piece of the puzzle is temperature monitoring. I put a sensor between the pump and the GPU to track the coolant temperature at its coldest point. That number is great for tweaking fan speeds and making sure I'm not cooking anything. Right now, my radiator fans use a thermostatic control based on fluid temperature. They start spinning at around 37 degrees Celsius, which is 100 Fahrenheit, and go full blast at 45 degrees, which is 113 Fahrenheit. Sure, that might sound high, but that's well within all the specifications. Plus, that wider temperature difference means more efficient heat transfer overall. Convection does a lot of heavy lifting in the radiators, and the fans usually hang around 300 RPM, making them basically inaudible. Being my first time dabbling in water cooling, I chose soft tubing. Everybody and their grandma told me hard tubing would be a nightmare for a first timer, especially since I'm not 100% settled with my loop layout. For coolant, I went with Alphacool's Tech Protect 2, which is a clear formula that's basically water plus biocides, so I get near water thermal capacity while keeping the nasties out. I did think about using UV reactive fluid, but after reading up on microparticles and potential discoloration, I decided against it. Black tubing helps to avoid also leaching issues where stuff leaches from the tubes into the liquid. I'm using Asus motherboard here, and let's just say the bundled Armoury Create software isn't my favorite. I still need a stripped down version of it to make the little OLED screen work, but otherwise I manage everything else with these two free apps. The fan control. This is my main tool for cooling management. It lets me set up multiple fan curves per header to get that sweet balance between performance and quiet operation. Because the system has so much thermal mass, I can use really gradual ramp up and ramp down speeds, so it basically stays silent even under heavy loads. I also run hardware info alongside it to grab sensor data that the fan control can't normally see itself. OpenRGB handles all my lighting. It can tap into the motherboard, GPU, keyboard and mouse LEDs, which is great for like set it and forget it kind of approach. I love the clean interface, and I can easily match the case lighting with whatever theme I'm in the mood for. So that's Mark 11 in a nutshell. A huge leap forward in my quest for quiet but powerful workstation. By carefully picking components and cooking up a few cool engineering tricks, I managed to get the best performance I've ever had without the thing sounding like a jet engine. What do you guys think? Let me know in the comments if there's something I could improve or if you have any tips from your own builds. If you like applications like the fan control and OpenRGB, consider donating to the developers as they do their stuff without any corporate backing. And the community needs that kind of tools, so we don't need to use Armoury Crate. As always, thanks for watching.